Good afternoon, students. Let us consider some more questions on the inverse of a function and composite of two functions. Let us consider the question. It is a function f from r positive to minus 7 to infinity. Now, here r positive means the positive real number to this semi-open interval minus 7 to infinity given by fx equal to 5x square plus 6x minus 9. Show that f is invertible with inverse of f given to be this. Now first we have to prove it. It is invertible. As usual, first we will prove that the function is 1, 1. Now let x1, x2 belonging to R positive such that their images are equal. If f of x1 equal to f of x2, this implies 5x1 square plus 6x1 minus 9 equal to 5x2 square plus 6x2 minus 9. Simplifying and making the factorization, we are getting this expression. Now here either this should be 0 or this should be 0. Either x1 minus x2 equal to 0, and but this expression can never be 0 because all these are what? Positive number, and the sum of positive number is always positive number. It cannot be 0. So therefore x1 minus x2 equal to 0. This implies x1 equal to x2. It means if the images are equal, then their elements are also equal. Therefore we can say function is 1, 1. Let us go for the function is onto function. It means we consider any arbitrary element from the codomain and we should prove for that value of y there is at least one element in the domain and its image is equal to the that arbitrary element. So let y belongs to its codomain minus 9 to infinity such that y equal to fx. Now y equal to fx means y equal to 5x square plus 6x minus 9. Now simplifying it, we write x in the terms of y. By simplifying, we are getting it is a quadratic equation. We can solve it by the discriminant method. So we are getting this value of x. Now r being what? R positive. It means the positive real number. So x must be equal to minus 3 plus minus 5y plus 54 by 5. Now considering only the positive values, so we are getting here under root 5y plus 54 minus 3 upon 5. We have to consider only the positive value that is belonging to what? R positive. So we can say we have taken an arbitrary element. For that arbitrary element has at least one pre-image in R positive. So we can say function is onto. And moreover we can prove it, its image is equal to what? We can prove that the image of this element is equal to y itself. So we can say the function is onto. Therefore function is 1, 1 and function is also onto function. Therefore we can say function is invertible. Now we have to find out inverse. Let its inverse be equal to k. Then it can be written as y equal to f of k. Then putting the value of the function here and solving to get the value of k. Again we are getting here k equal to minus 5y plus 54 minus 3 upon 5. And now this is the value of what? F inverse that we have to find out in the question. See the question again. The question is given to be like this. First we have to prove that it is invertible. Then we have to find out its inverse in the terms of y. It may be in the terms of x. It may be in the terms of y. Now function is invertible. First we have proved that the function is 1, 1. We can suppose two elements such that their images are equal. If images are equal, then the elements are equal. So we can say function is 1, 1. Whenever we have to prove the function is onto, we will take any arbitrary element from the codomain and then we are proving there is at least one x in the domain. So let y belongs to this such that y equal to fx. Then we have to put x in the terms of y. And for that we prove it that it is belonging to the domain of the function. For this x is this. So this belongs to R positive means the set of positive real number. And we can say function is onto, and moreover we can prove that the image of this image of this element is equal to again y. So therefore we can say the function is what? Onto function. Then we can find out the inverse of function, just simplifying it. we are getting the value of k, that is we have assumed the inverse of the function. Now let us consider another question. Show that function f from R to R given by this fx equal to 1 if x is greater than equal to 0. This is equal to 0 if x equal to 0. This is equal to minus 1 if x is less than 0. This type of function is known as signum function. This type of function is known as what? Signum function. And moreover, this function can also be defined fx equal to modulus of x upon x. If x is not equal to 0, then this is equal to 0. If x equal to 0, this is also the definition of the signum function. Now the function is given to be this. We have to prove that is neither 1 nor onto. Now as it is clear from the function, for x greater than equal to 0, the image of each element is equal to 1. Therefore f of 1, f of 2, f of 3, for all x greater than equal to 0, the value of f1, f2, f3 is equal to 1. And for this for x less than 0, it means f of minus 1, f of minus 2, and f of minus 3 equal to minus 1. It means the different element have the same image. So we can say that the function is not 1 function. Whether we have to prove now here in this function, now whatsoever the value of x, the value of fx is either 1, 0 and minus 1. It means this is what? The range of the function. Now here the range of the function, because the function is defined R to R, therefore the range of the function is not equal to codomain of the function. So we can say function is not onto function. Now let us see another question. Show that the function given from n to n given by this is bisective function. Function is like this: fx equal to x plus 1 if x is odd. It is equal to x minus 1 if x is even. We have to prove that it is bijective function. So let us, as usual, first we will prove the function is 1. Let us take x1, x2 belonging to n. Now here it is a set of natural number. First case here we are taking if both are odd function, because for the odd the function is x plus 1, for even the function is x minus 1. We are supposing let x1 and x2 both are odd function. Then f of x1 equal to f of x2. Then f of x1 is 1, x1 plus 1. F of x2 is what? x2 plus 1. Now this, if the images are equal, then the elements are equal. So we can say in this case the function is 1. Similarly, when x1 and x2 are both are even, such that f of x1 equal to f of x2. Now both are what? Even. Therefore they are defined by like this. It is what? x1 minus 1 equal to x2 minus 1. Again this implies x1 equal to x2. Now case third, we are assuming let x1 is even and x2 is odd. It means x1 is not equal to x2, because one we have suppose even, another we have suppose odd. It means x1 is not equal to x2. Now here f of x1 is what? x1 minus 1, and f of x2 is what? x2 plus 1. Now as x1 is not equal to x2 and also f of x1 is not equal to f of x2, so we can say the function is not so we can say the function is what? 1, 1. There are two ways to find the function is 1, 1. Either the images are equal, then the elements are equal. Another method is if the elements are unequal, then their images are also unequal. This is another way to find out the function is 1. Now the elements are not equal, their images are also not equal. So we can say function is 1, 1. Similarly, we can case another case if x1 is odd and x2 is even. Then again the elements are not equal and their images are also not equal. So we can say function is in all the four cases the function is what? 1, 1. Now we have to prove that the function is onto function. Again we can take any arbitrary element from the codomain. Now here if x belongs to n. Now first we take the case if x is odd. If x is odd, then x plus 1 is also even. If x is odd, then x plus 1 belonging to n is even. And the image of this is equal to, we are getting here f of x plus 1 equal to x plus 1 minus 1 by the definition of the function. this is equal to x. Now we have taken any arbitrary element from the codomain and we have proved that there is at least one element in the domain and the image of that is equal to x. So we can say in this case the function is what? Onto function. Let us case another case. If x is even, then x minus 1 is odd and it belongs to n. And the image of this again we are getting equal to x. So in both the cases, first we have taken x is odd, another we have taken x is even. In both the cases, the function is what? In both the cases, it has at least one preimage in the domain. And the image of that is the element itself that we have supposed here. So we can say the function is onto. Now here the function is 1, 1 and function is onto also. So we can say f is bijective function. Now let us take another question. The function is given to be this, x is not equal to 1 or minus 1. It is given in the question. Show that f of f inverse is identity function. It means we have to find out f inverse first here in this question. Now here the domain of f is given to be, because x is not equal to 1 or minus 1. Otherwise it can be defined for every real number. So the domain of the function is r minus 1, 1. This is the domain of the function. Now here let again we have to prove it. It is 1, 1. We are supposing two elements from the domain of the function such that their images are equal. If the images are equal, then we are proving that the elements are also equal. So we can say function is 1, 1 function. Again we have to prove that the function is onto function. Let y be any arbitrary element such that fx equal to y. Where y be any arbitrary element such that fx equal to y. Such that this can be written as fx equal to y, means x minus 1 upon x plus 1 equal to y. Then we have to put x in the terms of y. Now here it is very much clear y cannot be equal to 1. Then x cannot be defined. Now x is not defined at y equal to 1. Also the function is not defined at x equal to 1. And f of 1 is what? 1 minus 1 upon it is equal to 0. It means the value of y cannot be equal to 1 and value of y cannot be equal to 0. Therefore, we can say the range of the function is what? R minus 0. Therefore, range of the function is what? R minus 0. Now here, now we have to find out the inverse. Now let f is a function defined from what? R minus 1, 1, 2. F is a function, it's what? Domain of the function. Earlier it is given, it is the range of the function. So therefore f is a function defined from this to this. It inverse will be existing, that will be from this to this. Now here, therefore this function we have proved that what? F is a function, we have proved that it is 1, 1 function. We have proved that only for this value the function is what? Onto function. Therefore we can say for this function defining from this to this is 1, 1 and onto. Therefore hence it is invertible. And we can find out the inverse of the function. It is given by k equal to 1 plus x upon 1 minus x. So it is the inverse of the function for all x belonging to R to 0, 1. Now we have to, second thing we have to prove that f of f inverse. F of f inverse is given by f into f inverse x, putting the value of any f inverse x here, then simplifying, finding the value of fx by using it in the given function. We are putting the values of x here and getting this is equal to x. It means this is now the image of this element under f of f inverse is the element itself. So we can say this is an what? Identity function. See the question again. First, the function is given fx equal to this. We can easily define the domain of the function because at this value the function cannot exist. It is given in the question. And because it is what? Rational function, it can be defined for all real number except x equal to 1 and minus 1. So it is the domain of the function. First we can prove it is 1, 1 function. Then we can prove it is what? Onto function. Because it is the what? It can be defined on the real numbers. Now y be an arbitrary element such that fx equal to y, then taking x equal to 1 plus y upon 1 minus y. Now y cannot be equal to 1. Why? For y equal to 1, x cannot be defined. Therefore 1 cannot be in the domain of the function, in the range of the function. Also x is not defined at y equal to 1, and also it is given that x cannot be equal to 1. When x is 1, f of 1 is equal to 0. It means again it will not be the value of the image of the function. Therefore the range of the function is r minus 0, 1. Now it means f is a function from this to this, and this function is what? 1, 1 and onto function. Hence it is invertible. So we can find out the inverse of the function, and then we are proving that f of f inverse is equal to x. So we can say it is an what? Identity.